As I have discussed about Kevlar in my previous video, that it is used in bulletproof vest because it is known good for its impact resistance and toughness. So similarly, it is being used in aircraft industry as well for containment ring material in engines. Alright, so you can see that this is the structure of an aircraft engine which lies underneath the wing of an aircraft, which is known as a ponded engine. The structure of an aircraft consists of several sections, hot, cold, and you can see that there are fan blades and then a containment ring. So a fan blade of an aircraft moves at around the speed of 3000 RPM, means 3000 rotations per minute, plus minus 600. If a fan blade breaks, it might damage the casing and then break it through and then cause the secondary damage to other structure parts of aircraft like fuselage or the body of an aircraft, and the wings or primary controls like radars and rotors. So yeah, and ultimately leading to worse situations. To avoid such accidents and secondary damages, we have to place a material that can withstand the impact of fan blade so that it can remain inside the containment ring. So that's why we use Kevlar as a containment ring material. You have heard about bird strikes, right? Now, bird strikes are very common, and we know that the fan blade of an aircraft moves at around the speed of 3000 RPM. So when there's a collision between a bird and the fan blade, it can break off the fan blade. And if a fan blade remains inside the engine, it can damage the engine and it can catch fire as well. But only in 1 of 50 of such cases, it catches fire. And in such situations, the engine automatically stops and we have sister engines to carry out the rest of the flight, and we go for the emergency landing to the nearest airport. So yeah, our purpose was to save the people and limit the damage to aircraft, the secondary damages. What is a blade off or blade out testing? Now this image is by NASA, and in which they're showing that whenever an aircraft is manufactured, it has to go through some safety certifications, and for that they have to carry out at least 2 tests to make sure that the blade remains inside the containment ring. Right, so in this picture, you can clearly see that the blade that has been broke off has damaged the containment ring, yet it has stayed inside the ring. So previously they used high alloy steels or super alloys with cobalt and nickel as a containment ring material, and which becomes quite expensive. Super alloys are used in hot section of an aircraft to withstand high temperatures, and the containment ring lies in the cold section of an aircraft where high temperature is not such a requirement. That's why we have replaced the material with Kevlar to withstand the impact of fan blades. So these are the properties of Kevlar, and in which you can see that the density of Kevlar is quite lower than that of steel, which is a plus point, and the relative strength is greater, and then the flexibility and resistance to corrosion is also high. So yeah, these are some benefits of using Kevlar instead of steel. Another thing about Kevlar is that it can maintain its strength at cryogenic temperatures. Cryogenic temperatures lies at around minus 190 degrees Celsius. Yeah, it means that it can maintain strength at lower temperatures, and the temperature at high altitude where the plane flies is quite low. So yeah, it's better to use Kevlar instead of steel as it can maintain its strength at lower temperatures. So the only drawback about Kevlar is that it cannot maintain its strength at higher temperatures. It means that it cannot be used in hot section of an aircraft, but since the containment ring lies in the cold section, so it can be used in the cold section. Our purpose was to save the people and limit the damages to the aircraft, and we are successful in that by replacing steel from Kevlar. Thank you for watching my video, and for more informational videos like this, subscribe my channel. Thank you.